child for the manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a cost-friendly format.
Hello learners, I'm grateful for this opportunity to stand before you so that we can learn matters to do with business. The topic is business and its environment. In our last lesson, we defined business environment. We say that business environment refers to the factors or conditions that affect a business. And we say that these factors or conditions can be categorized into two.
Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi, and today we continue with our topic of discussion. The topic is acids, bases, and indicators, topic in Form 1 chemistry. So at this point, we are going to discuss commercial indicators. And this is in addition to what we discussed the last time, whereby we discussed the extraction of indicators from plant extracts. And we saw the disadvantages of those indicators that are obtained from plant extracts, and that is now why there is need for commercial indicators. So commercial indicators give consistent results. They can be stored for a long time for future use and so on and so forth. And we'll have various examples. We have, for example, an indicator that is called litmus. Litmus can either be in form of a solution called litmus solution. It can also be in form of a paper called litmus paper. We have other commercial indicators such as methyl orange. There is phenolphthalein. There is screened methyl orange. There are many. There are bromothymol blue. So there are several. But of course, we'll only mention the common ones, the ones that are commonly used in our laboratories. So we can say that common commercial indicators include, we have litmus, we have methyl orange, there is also screened methyl orange, there is phenolphthalein, there is a bromothymol blue. So all those, they are commercial indicators, but we'll mainly mention the litmus and the methyl orange and phenolphthalein because those are the common ones that we actually use. So we can first of all say that these indicators give consistent results. So they cannot give you results today and then tomorrow they give you results that are different. So they'll have to be consistent. That's why they are more recommended as compared to the simple ones that are obtained from plants. So these ones are basically the ones that we use. So they give consistent results and can be stored for future use. So at this point, we'll have a table showing the effects of commercial indicators on different solutions effects of commercial indicators on different solutions. So we'll put this as a table. So we'll have a solution being tested in the first column. Then here we can use litmus paper is one of the indicators, or we can still use the litmus solution. They just give the same results. Then we have methyl orange indicator, and then we have phenolphthalein indicator. So for example, we can take lemon juice. If you test it with litmus paper, the color turns red. So you can mention somewhere here that this is the color obtained using either of those indicators, using litmus paper. So when using a litmus paper, the color obtained is red with lemon juice. When you use methyl orange, the color here is pink. When you use phenolphthalein, it's colorless. So you can see that different indicators give us different colors with the same solution. On the other hand, if we use something like soap solution, with the litmus, the color will be blue. With methyl orange, the color will be yellow. And with phenolphthalein, the color will be pink. So you can see all of them are giving us different colors. We take an example of hydrochloric acid. In litmus, it will be red. In methyl orange will be pink. And in phenolphthalein will be colorless. So we can observe something here, that hydrochloric acid is behaving the same way as lemon juice in all the indicators. And that is an indication that lemon juice and hydrochloric acid are acidic. They are acidic. But soap solution is not acidic. That's why it's giving us different colors. If you take something like caustic soda solution, so this one will behave like the soap solution. Blue with litmus, yellow with methyl orange, and pink with phenolphthalein. So 2 and 3, they have similar properties. That means caustic soda solution and soap solution, they are bases. They are bases. That's why they are giving similar colors with the various indicators. If we take an example of distilled water, the litmus is purple, the methyl orange is orange. That means the color remains orange. Litmus, the color remains purple. Phenolphthalein, the color is colorless, it remains. So for distilled water, this is neutral. It's neither acidic nor basic. It's not behaving like the others. That shows that it has its own properties that are different. So the list can be long. We can have as many chemicals as we want. But something that is worth mentioning, we can say that from the above table, we can say A, lemon juice hydrochloric acid. We can still use sulfuric acid. All give similar, they give similar colors with different indicators. They give similar colors with different indicators. They are all acidic. All of them are acidic. That's why they are giving the same colors. Lemon juice, hydrochloric acid, even if we were to use sulfuric acid, it will give us all those colors. So that's an indication that all acidic substances will behave like that. On the other hand, we can say that soap solution, caustic soda solution, we can have potassium hydroxide, sodium hydroxide, and others not on the list. They also give similar colors with different indicators. With different indicators above. They are all basic. So they are all bases. So they are bases because they have their own color that they are giving us that is different from those that are acidic. Remember we said that the work of the indicators is to tell us, is this an acid or is this a base? If it is an acid, it gives you a certain color. If it is a base, it gives you a different color. Then we have distilled water that is giving us a completely different color from the others. So here distilled water, we are saying that it is neutral because the litmus remains purple. It doesn't turn red or blue. The methyl orange remains orange. Phenolphthalein remains colorless. So that is an indication that they are neutral. So you can say that distilled water and common salt solution even sugar solution, can also use it there. They do not change the color of indicators. They do not change the color of indicators above, i.e. they are neutral. They are neutral. And neutral means neither acidic, they are neither acidic nor basic. So they are not acids and they are not bases. Distilled water, common salt, sugar solution, those ones have no effect on the indicators. But you can see that lemon juice, hydrochloric acid, sulfuric acid, those ones are acidic. They are giving you similar colors. If it is using litmus, all of them are red. If it is using methyl orange, all of them are pink. If it is using phenolphthalein, they are colorless. So if the behavior is the same, then it means that they have similar properties or they have the same properties. So we can summarize that again and say that we can have the indicator, then we can have color in acid, base, and neutral solution. So for example, we can start with the litmus. In acid, it is red. In base, it is blue. In neutral, it's purple. So we are summarizing this from here. If it is methyl orange, in acid, it is pink. In base, it is yellow, as we can see there. And then in neutral, it's orange. And then finally, phenolphthalein. As another indicator. In acid, it is colorless. In base, it is pink. In neutral, it's also colorless. So this is the conclusion that we've got from the first table. We have an indicator, and then we have the various colors that it gives us. If, for example, the solution is acidic, if it is basic, and if it is neutral. So color in acid, litmus is red. In base, it is blue. In neutral, it's purple. Methyl orange, in an acid, it is pink. In a base, it is yellow. In a neutral solution, orange. Phenolphthalein, if you put it into an acid, it is colorless. In a base, pink. In a neutral solution, colorless. So that tells us that indicators give us different colors in an acid and different colors in a base. So you can have an assignment. So the first question, complete the table below, the indicator, the color it gives in an acid, the color it gives in a base, and in a neutral solution. So starting with phenolphthalein, methyl orange, litmus paper in each. And then question number 2, why is it advisable to use commercial indicators in the laboratory? Why is it advisable to use commercial indicators in the laboratory? So we'll stop there until next time. Goodbye.
Welcome to Manifested Publishers.
Hujambo mwanafunzi wa darasa la 8. Karibu katika kipindi hiki cha Kiswahili ambapo tutasoma msamiati. Na msamiati ambao tutasoma ni msamiati wa akisami. Naamini kwamba unatamani kusikia mengi kuhusiana na akisami, hasa katika lugha ya Kiswahili. Lugha ya Kiingereza unajua nyingi tu, lakini sasa leo tunajifunza akisami kwa lugha ya Kiswahili. Nataka hamu yako iwe katika kujua hizo akisami ni nini, na zaidi akisami zenyewe zinaitwaje kwa Kiswahili. Basi lisije kuwa tisho tena, kwa sababu leo hii hilo tatizo tunalitatua. Kwanza kabisa, wacha tuangalie maana ya neno akisami. Akisami, unapoeleza maana ya kisami, unaweza ukasema ni sehemu ya kitu kimoja kizima. Ni sehemu ya kitu kizima. Sehemu ni sehemu ya kitu kizima. Hiyo ndio akisami. Kwa lugha ya Kiingereza ni fraction. Ni fraction. Ni fraction. Lugha ya Kimombo ni fraction. Hivyo akisami ni fraction, ni sehemu ya kitu kizima. Ni sehemu ya kizima, sehemu ya kitu kizima. Eleza ni sehemu ya kitu kizima. Ama pia kamili. Najaribu kumaanisha nini? Nataka uchukue mfano, mifano tu, mifano. Unaweza ukawa na kitu kimoja kizima ambacho kimegawanishwa mara hizi. Angalia tu mfano. Kitu kimoja kinaweza kugawanishwa mara mbili kiasi hiki ama namna hii. Sehemu mbili zilizotoshana. Akisami ile ambayo tunaweza kutumia hapa, tuchukue sehemu moja kama hii. Tunaweza kusema kwamba akisami hii ni sehemu moja kati ya sehemu mbili. Ni sehemu moja kati ya sehemu mbili. Na hizo sehemu mbili ni sehemu mbili zilizounda kitu kimoja. Hivyo basi hii akisami inaitwa nusu. Nusu. Inaitwa nusu. Hiyo ni akisami tayari. Nataka tuangalie zaidi. Unaweza pia kuwa na kitu kimoja kimegawanishwa mara mbili. Mara tatu, samahani. Namna hii. Mfano zaidi. Kitu kimoja kinakuwa kimegawanishwa mara tatu. Kinaweza kikagawanishwa mara tatu. Kikija kugawanishwa mara tatu, kila sehemu inaitwa thuluthi. Hapa kila sehemu ikigawanishwa mara mbili, kila sehemu itaitwa nusu. Hii ni nusu na hii nyingine ni nusu. Na nusu ndio hii inaandikwa namna hiyo. Lakini tukija hapa, angalia, ukifanya hivi uchukue sehemu moja, hiyo sehemu moja ni moja kati ya hizo tatu. Na hiyo moja kati ya hizo tatu itaitwa thuluthi. 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 Mtazamaji, mwanafunzi, nataka usikilize hata namna ninavyotamka ni thuluthi. Thuluthi. Thuluthi moja. Hii ni thuluthi moja. Hii ni thuluthi moja. Na kama basi ni sehemu mbili ambazo tumeweka hiyo shading, unaweza ukasema kwamba ni thuluthi mbili. Thuluthi mbili. Lakini kwa sasa tumeonesha tu sehemu moja. Hiyo ni thuluthi moja. Pia kuna uwezekano wa kuwa na sehemu moja iliyogawanywa mara nne namna hii. Angalia. Kitu kimoja kikija kugawanishwa mara nne, kila sehemu inaitwa robo. Kama vile mkate. Mkate mmoja ukaja kugawanishwa mara nne, kila sehemu, kila kipande kitaitwa robo. Kwa mfano, hiki ni robo. Hiki kipande kimoja hiki. Hiki ni kipande kimoja kati ya vipande vinne. Hivyo basi hiki kipande kitaitwa robo moja. Robo moja. Kitaitwa robo moja. Kitaitwa robo moja. Aya, zaidi kuna uwezekano pia wa kitu kimoja kugawanishwa mara tano. Mara hii. Kitu kimoja kinaweza kugawanishwa mara tano. Kikija kugawanyishwa mara 5, basi sehemu moja, kila moja inaitwa humusi. Kila moja huitwa humusi moja. Moja kati ya hizo sehemu 5, basi kimoja, sehemu hiyo moja itaitwa humusi. Basi ni humusi moja. Humusi moja. Hiyo ni humusi moja. Humusi moja. Kuna uwezekano zaidi wa kitu hicho kimoja kigawanyishwe mara 6. Kigawanyishwe mara 6. Kuna uwezekano wa hicho kitu kimoja kiwe kimegawika mara 6. Kikija kugawika mara 6, kila sehemu inaitwa sudusi. Kila sehemu itaitwa sudusi. Kila sehemu kama hii moja hiyo itaitwa sudusi moja. Moja kati ya 6. Moja kati ya kutoka kwa hizo 6 itaitwa sudusi moja. Sudusi moja. Itaitwa sudusi moja. Itaitwa sudusi moja. Haya, zaidi tuna hicho kitu kizima bado kinaweza kikagawanyishwa mara 7. Angalia hapo mwanafunzi. Kitu kimoja kizima kikija kugawika mara 7, basi utapata kwamba hiyo sehemu moja itaitwa, hii sehemu moja katika hizo 7 itaitwa subui moja. Subui moja. Inaitwa subui moja. Inaitwa subui moja. Haya basi, kuna uwezekano zaidi wa hicho kitu kimoja kugawika mara 8. Na gawika mara 8 namna hii. Mwanafunzi angalia, hapa tuna sehemu 8 kutokana na kitu kimoja. Tuna sehemu ya kwanza, ya pili, ya tatu, ya 4, ya 5, ya 6, ya 7, ya 8. Hivyo basi hizo sehemu zote tuna sehemu moja kati ya hizo. Kila kipande kitaitwa dhumni. Hivyo basi ni dhumni moja. Dhumni moja. Hiyo ni dhumni moja. Dhumni moja. Angalia, dhumni moja. Moja kati ya hizo 8. Hiyo sehemu moja kati ya hizo sehemu 8, moja inaitwa dhumni 8. Basi kuna mfano mwingine mmoja. Mfano mwingine mmoja ambapo unapata haya, ukipata kwamba kitu kimoja kimegawika mara 9. Kitu kimoja kigawike mara 9 namna hii, utapata kwamba hicho kisehemu kimoja, kila kisehemu kinaitwa tusui. Kimoja kati ya 9 kitaitwa tusui moja. Tusui moja. Itaitwa tusui moja. Itaitwa tusui moja. Aya, zaidi tuna hizi sehemu. Tuseme ngapi? Sehemu moja, kipande kimoja cha kitu kama vile mkate, kimegawika mara 10. Namna hii. Iwe mkate ama chungwa ambalo limegawika mara 10. Umegawanya mara 10. Kila kipande kitaitwa ushuri. Kila kipande kitaitwa ushuri. Ushuri. Namna hiyo. Kitaitwa ushuri moja. Ushuri moja. Ushuri moja. Haya, nafikiri huo tu ndio msingi. Huo ndio msingi. Ujue kwamba kipande kimoja kati ya vipande viwili kitaitwa nusu. Hiki kingine 1/3 iwe ni thuluthi moja. Kisha hapa tunapata kuna robo moja. Hii nayo iitwe humusi moja. 1/6 iitwe sudusi moja. 1/7 iitwe subui moja. 1/8 iitwe thumni moja. 1/9 iitwe tusui moja. 1/10 iitwe ushuri moja. Kuna uwezekano pia wa kuwa na sehemu moja. Nataka tufikirie hivi. Umepewa mkate, ugawe kisha uchukue vipande vyako. Kisha ugawe mara 8, alafu uchukue vipande viwili. Ukichukua vipande viwili, tunaweza kusema kwamba umechukua vipande viwili kwa 8. Hiyo ina maana kwamba umechukua thumni 2. Umechukua thumni 2. Thumni 2. Thumni 2. Unaweza ukapewa kitu kingine ukigawe. Kije kitokea kwamba umempa mtu vipande 3 kutoka kwa 5. Kumbuka tulisema 1 kutoka kwa 5 ni humusi moja. Lakini hapa humusi sio moja, ni 3. Hivyo basi hii itaitwa humusi moja. Humusi 3, samahani. Ni humusi ndio, lakini humusi ngapi? Humusi 3. Humusi 3. Bila shaka nafikiri unaweza ukafikiria hii nyingine. Robo. Hapa hii ni robo, lakini sio robo moja, ni robo 3. Itaitwa robo 3. Itaitwa robo 3. Aya, chukua nyingine ya mwisho, mfano 7/9. 7/9. Kumbuka tulisema vipi? Kwamba 1/9 inaitwa tusui. Lakini hapa sio moja, ni 1 vipande 7. Vipande 7 kutoka kwa 9. Hiyo basi inakuwa ni tusui 7. Tusui 7. Tusui 7. Hivyo basi mifano ni mingi tu ambayo ninaweza nikakupa, na tayari nimeweza kukupa ile ambayo unaweza ukaifahamu kwa urahisi. Lakini nataka pia nikueleze hivi mwanafunzi kwamba hii 3/5, humusi 3, pia unaweza ukaiita 3/5. 3/5. Hii 3/4. Robo 3 pia inaweza ikaitwa 3/4. 3/4. 3/4. Kuna hii 7/9. 7/9 ambayo tuliita tusui 7, pia unaweza ukaita 7 kwa 9, samahani, 7 kwa 9. Basi mwanafunzi msomi wa lugha ya Kiswahili, nina mengi ambayo ninaweza nikakupa hapa kama mifano, lakini nataka nisitie hapa, nikupe kazi ambayo nataka niamini kwamba wewe utaweza kuifanya katika kipindi chako. Mazoezi ni muhimu. Mazoezi, fanya mazoezi zaidi ili uweze kufaidika. Zoezi nitaliandika hapa kwenye ubao, na nataka niamini pia hapo kwenye daftari lako umekuwa ukiandika yale ambayo nimeweza kuonesha hapa kwenye ubao. Nataka nifute niandike zoezi. Basi mwanafunzi, kazi yako ni nyepesi, rahisi tena sana, kama vile kula pipi. Unaambiwa andika akisami zifuatazo kwa maneno. Andika akisami zifuatazo kwa maneno. Ya kwanza ndiyo hiyo, 5 kwa 6. Pia unaweza iita lile jina jingine. Kisha tuna hii nyingine 1, kipande kimoja kati ya vipande 4. Hapa tuna vipande 7 kati ya vipande 10. Tuna kipande kimoja kati ya vipande 6. Tuna vipande 4 kwa vipande 7 na kadhalika. Andika majina ya akisami hizi kwa maneno. Hakikisha umeifanya kazi hiyo kabla ya mimi nawe kupatana katika kipande kingine. Basi nashukuru kwa kuwa umeandamana nami kuanzia mwanzo mpaka sasa hivi. Sikubomba.
Hello learner, welcome to our physics lesson where we continue with the quantity of heat as our topic. Quantity of heat, and in our lesson we'll continue with the determination of the specific heat capacity using the method of mixtures. So determination. So in the determination of the specific heat capacity, we are looking at the method of mixtures. By the end of the lesson, you should be in a position to solve numerical problems involving the calculations of the specific heat capacity or any other quantity that is asked, that is in the method of mixtures. So that is what we'll be looking at in this lesson. During our previous lesson, we were able to explain how we can calculate the specific heat capacity of, for example, a metal block by the method of mixtures. Something I'd like you to remember, we're saying that when we are determining the specific heat capacity, we assume that there is negligible heat loss, and maybe not unless we are told otherwise. But we assume that the heat loss is negligible, and therefore we can be able to work out our problems. So I want us to do a few examples on the determination of the specific heat capacity by the method of mixtures, so that you can see what is expected of you in questions. So we'll have 3 examples. Example 1. Example 1. So that's our question. Most of these questions will come as long as this one, or even longer than this one, but they are very interesting even to work out. So we are told that 70 grams of a solid initially at 25 degrees Celsius was carefully dropped into water in a calorimeter at 16 degrees Celsius. If the final constant temperature of the water and the solid was 54 degrees Celsius and the mass of water is 500 grams, determine the specific heat capacity of the solid. In this question, we are told to assume that the heat absorbed by the calorimeter is negligible. So we are not going to consider the heat gained by the calorimeter because we are told to assume that it is negligible. Then we are told take specific heat capacity of water to be 4,200 joules per kilogram per Kelvin. Now, whenever you are given such a question, the first thing that you need to ask yourself is, what is losing heat in this question and what is gaining that heat which has been lost by the other substance? So like in this question, we are having a solid initially at 25 degrees Celsius, which is being dropped into water in a calorimeter at 60 degrees Celsius. And then we are told that the final constant temperature of water and the solid was 55 degrees Celsius. So what is losing heat and what is gaining? We can see clearly that the water is initially at 60 degrees Celsius, but now when this solid is dropped, it goes down to 54 degrees Celsius. So here water is losing heat, and that heat lost by the water is being gained by the solid. So we'll start by saying that heat lost by water is equal to heat gained by the solid. So that is very key. Heat lost by water is equal to heat gained by the solid. Then after that, we can analyze and see what we are given so that now we can calculate. But before that, we can write first the formulas here. So heat lost by water, we know it will be given by the mass of water times the specific heat capacity of water times the change in temperature, which is equal to heat gained by the solid, mass of the solid, times the specific heat capacity of the solid, times the change in temperature. So in our question, we are told that the solid has a mass of, so the mass of the solid we have, which is 70 grams. We can change it into the SI unit, which is kilograms, so we'll have 70 all over 1,000 kilograms. Then the solid has an initial temperature of 25 degrees Celsius, so the initial temperature of the solid, we can write it that way, is equal to 25 degrees Celsius. It is dropped into water in a calorimeter at 60 degrees Celsius, so the initial temperature of water is 60 degrees Celsius. The final constant temperature is 54 degrees Celsius. And the mass of water, we are given as 500 grams, which is 500 all over 1,000 kilograms. And we have also been given the specific heat capacity of water to be 4,200 joules per kilogram per Kelvin. So we want to calculate the specific heat capacity of the solid. So that is the question. So when we have all this, then we can be able to calculate here. But before we get to that, we need to get the change in temperature for the water. Change in temperature, the temperature change for water. In our case, we have the initial temperature of the water, which is 60. The final is 54, and therefore the change will be 60 minus 54, which is 6. Then we also need to get the change in temperature for our solid. Initially, the solid is at 25 degrees Celsius, and the final temperature is 54. So we have 54 minus 25. So what do we end up getting? We end up getting 29. That is our change in temperature for the solid. So that's what we have. So we now want to apply this formula. So we are saying that mass of water times specific heat capacity of water times change in temperature is equal to mass of the solid times the specific heat capacity of the solid times the change in temperature. So we substitute what we have been given. So what is the mass of water? From there we have 500 all over 1,000. Specific heat capacity of water is 4,200. Change in temperature for water is 6. Is equal to mass of the solid, which is 70 all over 1,000. Specific heat capacity of the solid is what is in question, and the change in temperature for the solid is 29. So that is what we have. So you just use your calculator and find what you have. So we have 500 divided by 1,000 multiplied by 4,200 multiplied by 6. So you get 12,600. So on this side you get 1,200, 600 is equal to, on the other side we are multiplying 70 divided by 1,000. We are multiplying by 29. So we get 2.03. 2.03 multiplied by the specific heat capacity of the solid. So we end up getting 12,600 is equal to 2.03 multiplied by the specific heat capacity of the solid. And therefore, to get the specific heat capacity of the solid, we divide both sides by 2.03 divided by 2.03. So we have that cancelling. So we have the specific heat capacity of the solid to be 12,600 divided by 2.03, which you end up getting as 6,000. So you end up specific heat capacity of the solid will be 6,206. Point, we can write to 2 decimal places, so it will be 0.90. And therefore, that is 6206.896552, which we round off to be that. So our specific heat capacity of the solid is 6,206.90 joules per kilogram per Kelvin. And that is the specific heat capacity of the solid. Hoping that it's clear. So you need to note that here water is losing heat, and it is losing heat to the solid. So we are saying heat lost by water will be gained by the solid. So when that solid at 25 degrees Celsius is dropped into the water at 60 degrees Celsius, the final temperature becomes 54 degrees Celsius. So heat lost by water is equal to heat gained by the solid. And as we said, the formula for heat lost, or the formula for calculation of heat energy, mass times specific heat capacity times change in temperature. Here it is the change in temperature for water, and here is the change in temperature for the solid. The solid changes from, the temperature of the solid changes from 25 to 54, for water from 60 to 54. So you find what you have been given to get what is in question, and you get it to be that. So I want us to look at another example. Example 2. So we move on to our next example, example 2. So as I said, you can see the question. So a block of metal of mass 0.15 kilograms at 100 degrees Celsius was transferred to a copper calorimeter. So we have our copper calorimeter of mass 0.4 kilograms containing a liquid of mass 0.8 kilograms at 20 degrees Celsius. So then we are told that the block and the calorimeter with its contents eventually reached a common temperature of 40 degrees Celsius. So we are given the specific heat capacity of the aluminium block. So our block here is aluminium. So this aluminium block is 900 joules per kilogram per Kelvin. That of copper. And that of copper is 400 joules per kilogram per Kelvin. Calculate the specific heat capacity of the liquid. So that's another question. So in this again, we need to know what is losing heat and what is gaining heat. So in this we have a block of metal at 100 degrees Celsius transferred to a copper calorimeter containing a liquid. So here we have a copper calorimeter and a liquid which we don't know. And we are told that the block and the calorimeter with its content eventually reached a common temperature of 40 degrees Celsius. So you can see this block, this aluminium block, is actually aluminium block. It is not a block, it's simply aluminium block. You can use the symbols Al, aluminium block of metal. So we have this aluminium block which was initially at 100 degrees Celsius and then it attains a common temperature of 40 degrees Celsius, meaning that the block is losing heat. So here, the heat that is lost by the aluminium block is being gained by the copper calorimeter and also the liquid. So the liquid and the calorimeter gain heat which is lost by the aluminium block. Hoping that that is clear. This can be seen from the temperature of aluminium dropping from 100 to 40 degrees Celsius and that of calorimeter and the liquid rising from 20 to 40 degrees Celsius. So we can start by saying heat lost by the aluminium block is equal to heat gained by water and heat gained by the calorimeter. In this question, the calorimeter does not have a negligible heat capacity. In this, we have to put it into consideration. So we have heat lost by aluminium block is equal to heat gained by water. Sorry, not water. We are used to water. In our case here, it's not water, it is the liquid, sorry. Heat gained by the liquid plus heat gained by the calorimeter. Heat gained by the liquid plus heat gained by the calorimeter. So in this, heat lost by the aluminium block will be given by mass of the aluminium. We can use just a small letter A for that. Multiplied by the specific heat capacity of aluminium, multiplied by the change in temperature of the aluminium, which is equal to heat gained by the liquid, mass of the liquid, multiplied by the specific heat capacity of the liquid, multiplied by the change in temperature for the liquid, plus heat gained by the calorimeter given by mass of the calorimeter times the specific heat capacity of the calorimeter multiplied by the change in temperature for the calorimeter. And remember, this calorimeter is made of copper. It's made of copper, and that's why we have been given the specific heat capacity for copper. So after that, then we need now to come and analyze the question. What have we been given? So we are given the mass of the metal mass of the metal block, which is aluminium. So mass of aluminium, 0.15 kilograms. We've also been told that it is at 100 degrees Celsius. The initial temperature for aluminium is 100 degrees Celsius. Transferred to a copper calorimeter of mass. So the mass of the calorimeter is 0.4 kilograms, containing a liquid of mass 0.8. So the mass of the liquid is 0.8 kilograms at 20 degrees Celsius. So the initial temperature of the calorimeter and the liquid, for the calorimeter and the liquid, is 20 degrees Celsius. The block and the calorimeter with its contents eventually reached a common temperature of 40 degrees Celsius. So the final temperature, that constant temperature, is 40 degrees Celsius. So given that the specific heat capacity of aluminium is 900 joules per kilogram per Kelvin, and that of copper calorimeter is 400 joules per kilogram per Kelvin. So we are told determine the specific heat capacity of the liquid. So that is our question. Very interesting. So we just come and rewrite what we have here. Mass of the aluminium times the specific heat capacity for aluminium multiplied by the change in temperature for aluminium is equal to mass of the liquid times specific heat capacity of the liquid times the change in temperature for the liquid, plus the mass of the calorimeter, which is a copper calorimeter, times the specific heat capacity of copper times the change in temperature for that calorimeter. Then we need to note what are the changes in temperature. The change in temperature for the metal block aluminium will be the initial temperature is this, and the final steady temperature is 40. So the change will be 100 minus 40. And then for the liquid and the calorimeter, their initial temperature is this, the final temperature is that. So it will be 40 minus 20. So we just find what we have. Mass of the aluminium block is 0.15. Specific heat capacity of aluminium is 900. Change in temperature from 100 to 40. So it is 100 minus 40 is equal to mass of the liquid, which is 0.8. Specific heat capacity of the liquid is what we are looking for. Change in temperature for the liquid. Initially it was at 20, final is 40, so it will be 40 minus 20. Then plus mass of the copper calorimeter, mass of the calorimeter, which is 0.4, times the specific heat capacity of the calorimeter, which is 400, then multiplied by the change in temperature. Temperature of the calorimeter is also changing from 20 to 40. So it is 40 minus 20. And that's what we have. So using our calculator, you just come and multiply. We can multiply this, all of it, where we have 0.15 times 900 times 100 minus 40, which is 60. So you end up getting 8100 on this side is equal to, we can multiply here, we are having 0.8 multiplied by 20, you get 16, then multiplied by the specific heat capacity of the, plus on that other side we have 0.4 multiplied by 400 multiplied by 20, which is 3200. So we can now be able to get the specific heat capacity for that liquid. So here we have 8100. We can take this to the other side, minus 3200 is equal to 16 multiplied by the specific heat capacity of the liquid. So we'll have 8100 minus 3200 is equals to 16 multiplied by the specific heat capacity of the liquid. To remain with specific heat capacity of the liquid here, we divide both sides by 16, and that one will cancel. And finally, therefore, our specific heat capacity for the liquid, the specific heat capacity for the liquid will therefore be equal to 8100 minus 3200 divided by 16, which we end up getting using our calculators. We have 8100 minus 3200 then divided by 16. So you end up getting your answer as 306.25. This is specific heat capacity in joules per kilogram per Kelvin. Did you get that? So that's how we get the specific heat capacity. 306 or 306.25 joules per kilogram per Kelvin. So it's very easy. First thing, what is losing heat, what is gaining, and that can be shown by the drop in temperature or the rise in temperature. So you can be able to tell what is losing heat and what is gaining. Number two, you need to write that formula after you've written the equation. Write the formula here. Then you can see, analyze and see what is given. Then now you can be able to substitute those letters with the values that you have been given, and you'll be able to calculate what is in question. So finally, example 3. So example 3, we see what is given. It is not a must that you ask to get the specific heat capacity. You can even be told to find the temperature, like the question that we want to do. That's our question 3. We can read it. An iron block of mass 20 grams is left in water boiling at 95 degrees Celsius for some minutes, then transferred quickly to a well-lagged copper can. So it must not be a calorimeter. In this, we are told it is a well-lagged copper can. So this block, before we move on, this block which is left in boiling water at 95 degrees Celsius, it means that it will also acquire the same heat as the boiling water. So then it is transferred quickly to a well-lagged copper can of mass 14 grams containing 16 grams of water at 20 degrees Celsius. Note that the mixture is well stirred and the final temperature T is noted. Given that the specific heat capacity of copper is 400 joules per kilogram per Kelvin, for iron is 416 joules per kilogram per Kelvin, and that of water is 4,200 joules per kilogram per Kelvin, find the value of T. Now, let's solve the question together. By now, you know what is losing heat and what is gaining. Because in this question, we have an iron block. It is first left in boiling water at 95 degrees Celsius, meaning that it will also attain the 95 degrees Celsius. So that is the initial temperature of the block. Then it is transferred now into a copper can, which contains water, and it is at 20 degrees Celsius. So that tells you automatically that the iron block will lose heat because you can see that this is at 20 degrees Celsius, this is at 95 degrees Celsius. So they lose heat to the copper can and the water. So here we can say heat lost by the iron block is gained by the copper can and the water. So that is the first equation to have, that heat lost by the block will be gained by the copper can and also gained by the water in that can. So we start by that. So heat lost by the iron block is equal to heat gained by 1 water plus heat gained by the copper can. So make note of that. Then we can write the formula. Heat lost by the iron block will be given by mass of the iron times specific heat capacity of iron times the change in temperature of iron is equal to mass of water, specific heat capacity of water times the change in temperature for water, plus heat gained by the copper can given by mass of the copper can times the specific heat capacity of the copper can multiplied by the change in temperature for that copper can. So that's what we have. Then we move on and now analyze the question. So we have an iron block of mass. So the mass of iron is 20 grams, which is the same as 20 all over 1,000 kilograms. Then left in boiling water. So it attains a temperature. The initial temperature of iron is 95 degrees Celsius. Then transferred to a well-lagged copper can of mass. So the mass of the can is 40 grams, which is the same as 40 all over 1,000 kilograms, containing 16 grams of water. So the mass of water is 60 grams or 60 all over 1,000 kilograms of water at 20 degrees Celsius. So the initial temperature of water and also the can, the water and the can is 20 degrees Celsius. Mixture is well stand, it attains a final temperature. So the final temperature of that mixture is T. So we are going to find that T, and we are given that the specific heat capacity of the copper is 400 joules per kilogram per Kelvin. Then the specific heat capacity of iron is 460 joules per kilogram per Kelvin. And the specific heat capacity of water is 4,200 joules per kilogram per Kelvin. Very easy. So we want to find the final temperature. Now before we calculate it, do you expect it to be more than 20 or less than 20? Because here we are saying that this block, or at 95 degrees Celsius, is transferred into this copper can containing water at 20 degrees Celsius. So we expect that when it is transferred, this 20 degrees Celsius will now be more, it will increase. And this temperature of a block will go down so that they can meet at a certain temperature, a constant temperature, when the iron transfers heat to the water and the can. So from that, before we get to our calculations, then we can therefore say that the change in temperature for the iron will be, initially it was 95, and then the final will be T. T will be smaller. Then the change in temperature for the water and also the copper can will be The initial one, we have 20, the final one is t, but we know t is greater than 20. So it will be t minus 20. So take note of that. So now we can move on. We have here our formula, mass of the ion times specific heat capacity times change in temperature. We can write it here. Good. So mass of the ion, 20 all over 1,000. Specific heat capacity, 460. Change in temperature for ion is 95 minus T. So big in is equal to mass of water. Mass of water is 60 over 1,000 times specific heat capacity of water. Change in temperature for water, we've said it will be T minus 20. Then plus mass of the copper can, where is the mass is here, 40 all over 1,000 times the specific heat capacity of the copper, which is 400, then multiplied by the change in temperature, which is the same as for water, that is T minus 20. So that's what we are going to have. So we can now solve this part. So you just take your calculator and you find 20 all over 1,000 multiplied by 460. You can leave it at that. You get 9.2 into bracket 95 minus T. Cross the bracket is equal to 60 divided by 1,000 multiplied by 4,200. You get 252 into bracket T minus 20. Plus finally we have 40 divided by 1,000 multiplied by 400. We get 16 into bracket T minus 20. So now we can open those brackets. We have 9.2 multiplied by 95. We get 874 minus 9.2t is equal to, we open the bracket here, 252t minus 252 by 20, which is 5040. Then plus, open here, we have 16t minus 16 by 20, which is 320. So that's how our equation will look like. Then now we can bring the like terms together so that we'll be able to get the value of T. So we have 874 minus 9.2T is equal to 252T minus 5040, then plus 16T, then minus 320. So we can have here 874. We can take this to the other side. So this one we take it to the other side, we'll have plus 5040. This one again we have plus 320, which will be equal to 252T plus 16T. Then when we take this other T to the other side, we have plus 9.2T. So that's what we have. We can again fill that in our calculator. So we have 874 plus 5040 plus 320. We get 6234, which is equal to 252 plus 16 plus 9.2, which is 277.2 T. So we want to get the value of T, so we have 6,234 equal to 277.2 T. We can divide now both sides by 277.2, 277.2. We can cancel that, and therefore our T will be 6234 divided by 277.2, which will give us to one decimal place 22.5 as our answer. And since that was now the final temperature of the content. Therefore, it means that our T is 22.5 degrees Celsius. So you can see it is higher than 20 but lower than 95 degrees Celsius. So that's how you are supposed to go about that question. It's just the same as the others, only that in this we are asked to get the value of T. So you can be asked to get any value. You can even be told to get the specific heat capacity of water, the specific heat capacity of iron, or any other. But the key thing is what is losing heat and what is gaining. Then from there, you need to remember the formula for heat energy. The formula for heat energy, that should be one guiding point. Formula for the heat energy, which we are saying that heat energy is given by mass times specific heat capacity times change in temperature. So this is very key, where Q is the heat energy or the quantity of heat or the amount of heat in joules, where M is the mass of the substance in kilograms, C is the specific heat capacity in joules per kilogram per Kelvin, and theta is the change in temperature. This is the change in temperature in Kelvin. So you need to know that so that you can be able to work out all what we've been able to. So I'd like to leave you with a question. So a question for you. So that's the question. A student heated 20 kilograms of water to a temperature of 80 degrees Celsius. He then added X kilograms of water at 15 degrees Celsius, and the final steady temperature of the mixture is 40 degrees Celsius. Given that the specific heat capacity of water is 4,200 joules per kilogram per Kelvin, determine the value of X. So remember, here we are having two liquids. The two of them are water. The other one is, again, is water. So here we have part of water. So we can say that some of the, we have some of this water, the 20 kilograms water, which is losing heat. And then the X kilograms water is gaining heat. So you can be able to apply what we have been able to look at and find the value of X. And X here is the mass of that water. So during our next lesson, we'll continue with the determination of specific heat capacity, but now we look at the electrical method. Thank you.
Hello pupil and welcome to the program. I am your mathematics instructor, Philip Sagwa. For those of you who are joining us for the first time, in conjunction with TV47, we have been providing tuition for primary school pupils and secondary school students. These videos can be downloaded from the website that is being displayed on your screen. In today's lesson, we are going to learn about measurement, and this is primary mathematics. Primary mathematics for standard 6. Standard 6. The topic is measurement. The topic is measurement. So I want you to write down measurement. 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 Pupils, by the end of this topic, you are should be able to do 6 things. Number 1, you should be able to recognize and identify the millimeter as a unit of measuring length. Number 2, you should be able to convert millimeters to centimeters and vice versa. Number 3, you should be able to recognize and identify pi as a relationship between circumference and diameter. Then number 4, you should be able to work out problems involving circumference of a circle. Number 5, you should be able to work out area of triangles, squares, rectangles, including borders and shaded regions. Then lastly, you should be able to recognize and identify the hectare as a unit of measuring pieces of land. Pieces of land. I'm aware, learners, that this is not the first time you are encountering this topic. We covered this topic in the previous classes, and I know you are familiar with the centimeter, meters, and kilometers as units of measuring length. Now, before we get into the topic measurement, I want us to do some problems involving conversion of centimeters to meters and vice versa, meters to kilometers and vice versa. That is what we covered in the previous lesson. So in our today's lesson, in this lesson, we're going to do revision of the work that we covered in our previous classes, and we will work out problems from the pupils book. Ensure that you have this book when you come to these classes. This is the pupils book. We are going to work out some problems from exercise number 73, and this is revision of the previous work done in standard 5 and standard 4. Exercise number 73, question 1 says, convert into meters. Convert into meters. A, 200 centimeters. This is examples. Convert into meters. Convert into meters. A, 200 centimeters. B, 900 centimeters. B, 900 centimeters. C, 500 centimeters. Convert 200 centimeters into meters. Here is the answer. So, pupil, when I'm writing, you also write. Okay? How do we convert centimeters to meters? Centimeters to meters. 200 centimeters to meters. You will recall, learners, that 100 centimeters is equal to 1 meter. That's what we learned. 100 centimeters is equal to 1 meter. For example, I have my ruler here. The measurement or the length of this ruler is 100 centimeters. If you are to measure this ruler in centimeters, then from this point to this point, the measurement is, or the length is 100 centimeters. So 100 centimeters is equal to 1 meter. All right? 100 centimeters is equal to 1 meter. 100 centimeters is equal to 1 meter. 100 centimeters is equal to 1 meter. That is a very important statement that you need to know, because learners, you want to convert centimeters into meters. before we can convert centimeters into meters, you need to know that 100 centimeters is equal to 1 meter. So in answering part A, we write 100 centimeters is equal to 1 meter. We are to convert centimeters into meters. Then we come here and say, therefore, if 100 centimeters is equal to 1 meter, therefore 200 centimeters will be equal to how many meters? Will be equal to how many meters? Learners, how do we answer that question? It's a question. We'll come here and write, we get the reciprocal of these two measurements. So we are going to write 200 centimeters over 100 centimeters. All right, 200 centimeters over 100 centimeters times 1 meter. So you can see here, pupil, these centimeters will cancel out with these centimeters. These 2 zeros will cancel out with these 2 zeros. So we are going to remain here with 2 times 1 meter. Okay, 2 times meter. So we have 2 meters over 1, which is equal to 2 meters. So the answer here is 2 meters. That is correct. 200 centimeters is equal to 2 meters. 200 centimeters is equal to 2 meters. Then let us answer part B. Convert 900 centimeters into meters. Part B. Convert 900 centimeters into what? Into meters. So we'll write this first statement, very important statement. I come and say 100 centimeters is equal to 1 meter. Therefore, 900 centimeters will be equal to how many meters? Therefore, 900 centimeters will be equal to how many meters? Just the same way I did here, I'll come and get the reciprocal of these two. I write here 900 centimeters over 100 centimeters, 100 centimeters times 1 meter. These centimeters will cancel out. This centimeter cancels that centimeter. These 2 zeros is cancels out with these 2 zeros. So we remain here with the 9 times 1 meter over 1, which is equal to 9 meters. This is equal to 9 meters. This is correct. That is the answer. Then we work out part C. Convert 500 centimeters to meters. C. Convert 500 centimeters to meters. We know 100 centimeters is equal to 1 meter. Therefore, 500 centimeters will be equal to 500 centimeters over 100 centimeters. 100 centimeters times 1 meter. Then we work it out. We simplify. We cancel these centimeters. We cancel these zeros. We remain with 5 times 1 meter. So that will be 5 meters divided by 1, which is equal to 5 meters. This is equal to 5 meters. And that is the answer to the question. Pupil, that is how to convert centimeters to meters. Convert centimeters to meters. Convert centimeters to meters. And that, pupil, will mark the end of our today's lesson, where we've revised what we covered in our other lower classes. And the lesson is never complete before I give you an assignment. I want you to go and work out. This is your assignment. Assignment. It has been said, practice makes man perfect. So I want you to go and practice from the pupil's book. This is pupil's book. This is your book. All right. Go to page 100. Page 100. All right. Go to page 100, pupil's book, and do exercise 73, exercise 73, question 2 up to question 7. Question 2 up to question 7. Make sure you do the assignment. A good student is the one who takes instructions. Make sure you do the assignment before coming to the next class. We will be providing more videos in this series of primary mathematics. Thank you and God bless you.
How do you do? Welcome to today's lesson. My name is Wilson Mwangu. In the previous lesson, we learned about conditional sentences using the word if. We said, for example, if conditional, for example, in a sentence, if it doesn't rain, if it doesn't rain, I'll visit you. The condition here is the raining. If the rain does not fall, then certainly I'll pay you a visit. So the second part of this sentence depends on the first part for it to take place. So we call that an if conditional. In today's lesson, we want to learn something about combining two nouns with a number, what we call a numerical. Numerical is just a number, okay? So you can say a numerical is a number. For example, 20, number 10. When you say 10, 20, 5, 50, 100, this is a number. So we want to combine a number with a noun and another noun in sentences. So this will be our focus of today's lesson. So this is a lesson objective. By the end of the lesson, the learner should be able to use the above formation in a sentence. Let me give an example, and I'm going to use this ruler here. Okay? How long is this ruler? How long is it? This ruler is 1 meter long. Okay, so we say the ruler (1 meter) is 1 meter long. We can say this is a 1 meter ruler. This is a 1 meter ruler. We have used the word 1. These are numerical, plus meter, a noun, plus a noun. So these are numerical plus noun plus noun. This is a 1 meter rule, right? Let me give you a second example. The example here, and I have some money with me. Look at this amount of money. How much is this? What's the worth of this? Okay. So this note is worth 200 shillings. So you can say this note $200 shillings. This note is worth 200 shillings. Now we can change this sentence so that you have this order, so that you have a number, a noun, and a noun. A note is a noun. 200 is a number. Okay? So we shall say let me write it again. We shall say this. This is a 200 shilling note. This is a 200 shilling note. Now in this sentence, we have 200 as our numerical number, the worth or the value. Then you have shilling, a noun, and then note as a noun. Okay? Please note, we don't say 200 shillings. No, we say 200 shilling. It's wrong to say 200 shillings note. When this word comes, when you have two nouns, we don't add an S here. We say 200 shilling note. Now, look at this coin. I have a coin in my hand. I have a coin in my hand. I have a coin here. This coin is worth 20 shillings, okay? So you can say this coin is worth 20. This coin is worth 20 shillings. Now we want to change so that we have the numerical noun. We have this order, numerical and noun formation. So we shall say this is a 20 shilling coin. This is a 20 shilling coin. Here is our numerical. We have our noun. We have another noun. This is a 20 shilling coin. Please note, we don't say 20 shillings coin. No, we say 20 shilling coin. All right? Let me give you some more examples. If you live in a house, that has 4 doors, okay? Your house has 4 doors. We shall say you live in a 4-door house. You live in a 4-door house. We don't say 4 doors, no. You live in a 4-door house. 4 is the numerical, noun plus noun, all right? We say you live in a 4-door house. More examples. Let me give you more examples so that we make this very, very clear. If your house has 2 bedrooms, we say you live in a 2-bedroomed house. You live in a 2-bedroomed house. Again, we have a numerical, we have noun, we have another noun. Okay? Another example, during long holiday, at times we are given 4 weeks as your holiday, okay? Yeah, so we say the holiday lasted 4 weeks. So we can say we are given a 4-week holiday. This is how you change the sentence into, sentence. So we say we are given a 4-week holiday. The holiday lasted 4 weeks. Okay, so you change. We are given a 4-week holiday. Okay. Maybe you want to take a break of 2 hours. Okay, so you take a break of 2 hours, lasting 2 hours. Okay, of 2 hours. We shall say you have taken a 2-hour break. You have taken a 2-hour break, and we put a hyphen between these 2 words. You have taken a 2-hour break. All right. Another example. You want to do an exam that lasts for 3 hours. Okay. A test that takes 3 hours. We shall say this is a 3-hour test. This is a 3-hour test. We don't say a 3 hours test. No, a 3-hour test. Another example. Another example. The chair that you are sitting on has 4 legs, okay? So the chair the table has 4 legs. So we shall say this is a 4-legged table. This is a 4-legged table. All right? So we have our number 4, a noun and a noun. These are numerical, a noun and a noun. So that's how we form this kind of formation, where we have a noun, and a noun. And this, the first noun actually acts as an adjective. All right? Another example. Maybe you are reading a book that has 30 pages. The book has 30 pages. So we shall say this is a 30-page book. This is a 30-page book. Please note, we don't say 30-paged. No, we say 30-page book. All right? 30-page book. The last example, you want to take a walk, or maybe you're on a journey that will take you 3 hours, okay? So the journey takes 3 hours. So we shall say this is a 3-hour journey. This is a 3-hour journey. This is a 3-hour journey. We don't say 3 hours. We say 3-hour journey. All right? Yes. So these are enough examples of how we have this kind of formation where we have a numerical plus a noun and a noun. And this numerical acts as an adjective. It's specifying the amount of time, because adjectives come before nouns, and they specify the amount of time, what we call quantity adjectives. This 3-hour, 30-page, 4-legged table, right? So I want us to look at we look at an exercise that will guide us even much more. question reads, match the sentences in A with the correct sentences in B. A, the operation took 5 hours. The holiday took 1 month. The course took 1 year. The book has 60 pages. The flight took 8 hours. Here on the other side, you have it was a 1 month, 1 meter ruler. It is a 1 year course. It is a 5-story building. It was a 5-hour operation. It is a 3-legged stool. Then here we have the stool has 3 legs. The ruler was 1 meter. The bag of maize was 50 kilograms. The race was 10 kilometers long. The building has 5 stories. Then we have on the side of B, we have it was a 50-kilogram bag. It was a 10-kilometer race. It was a 1-month holiday. It was an 8-hour flight. It was a 60-page book. So we are meant to match A with B, okay? So number 1, the operation took 5 hours. So we shall say it was a 5-hour operation, all right? The operation took 5 hours. It was a 5-hour operation. So number 1, it was a 5-hour operation. That's number 1. Number 2, so this is number 1. Number 1. Number 2, the holiday took 1 month. So holiday took 1 month. It was a 1-month holiday. So number 2, so this is number 2. It was number 3, the course took 1 year. The course took 1 year. It was a 1-year course. So this is number 3. It was a 1-year course. Number 4, the book has 60 pages. The book has 60 pages. It was a 60-page book. So this is number 4. "60-page book." Number 5, the flight took 8 hours. Flight took 8 hours. So we shall say it was an 8-hour flight. So this is number 5. It was an 8-hour flight. Now, my dear learner, I want you to do the remaining 5 questions, okay? You match A with B. In summary, today you have learned about adjectives that are formed by combining a number and a noun, all right? For example, if you can see, you can look at this example here. It was a 5-hour operation. 5-hour is 5 is a number, what we call a numerical. Then hour is a noun plus operation, a noun. But these two are acting as an adjective, all right? Because they are describing the operation. how long it took. It took 4 hours, it took 5 hours. Then I've said we put a hyphen between the number and the first noun. We put a hyphen. And lastly, the noun, the first noun should be in singular form. For example, we say a 60-page book, right? You don't say a 60 pages book, no. A 60-page book. So the word page should remain in singular form. So that's what you have learned today, my dear learner. We shall end today's lesson at that moment. Until next time, I've been your teacher, Wilson Mwangu. Thank you so much and be blessed.
Enroll your child for the manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a cost-friendly format.
Hello learners, I'm grateful for this opportunity to stand before you so that we can learn matters to do with business. The topic is business and its environment. In our last lesson, we defined business environment. We say that business environment refers to the factors or conditions that affect a business. And we say that these factors or conditions can be categorized into two: the internal business environment and the external business environment, or the internal environmental factors or the external environmental factors. Then we discussed three factors under the internal business environment, which are the objectives of the business. We also discussed the management policies and management styles. Today we will continue discussing the other factors, internal factors that influence the success or failure of a business. So the subject is business studies. Business studies form 1. The topic is business and its environment. Business and its environment. Hope learners, you are ready to learn. And just to remind you, I also gave you an assignment in our last lesson, which is my hope that you have done. Now, we will continue discussing the business internal environment, and we say that the internal environment refers to the factors which are within the control of the business. All right? Within the control of the business. The business can determine or can use these factors to its advantage. And to its advantage, we mean the business can use these factors to make the company profitable, make the company grow, and make the company survive. Make three things. Businesses seek to make profit, number one. Number two, businesses seek to grow. Number three, businesses also seek to survive. We say that growth is seen in terms of the output, can also be seen in terms of the size and sales volume. That's what we learned last time. And we also say that survival can be seen in terms of the stability of the business. That is ensuring that the business continues to operate for a long period of time. So these are, we want to continue internal environment. Internal environment. In our last lesson, we gave three factors. We discussed three factors. Three factors. The first one being business objectives. Objectives. We had objectives. Objectives. Then number two, management policies. Management policies. Then we had management style. Management style. Today we want to discuss the other factors, internal factors. And the next internal factor is in relation to personnel. Personnel. These are employees. This is viewed as an internal factor because it is within the control of the company to determine what kind of employees the company will hire. And personnel refers to the employees working in an organization. Employees will only be useful if they have the necessary knowledge and skills. These employees, we are talking about employees or personnel knowledge. Number one, knowledge. Then skills and values. Personnel knowledge, personnel skills, and personnel values. So if employees have skills, they have the required values and knowledge, then that company is most likely to grow. Okay, it's most likely to grow. It is important for management to ensure that the people who are hired to work for the business have the necessary knowledge, have the necessary skills for their jobs. If you want to hire an accountant, for example, then the accountant must have the accounting skills. He must have the knowledge and the skills. It's very important. If you're hiring an engineer to work for the company or the business, then he must or she must have the relevant or necessary engineering skills. So a business can increase the productivity of its workers, can increase the skills or productivity of its workers by training, okay? Through training, even after hiring the employees, learners, then it may be necessary for these employees to keep on training even while they are working for the business. Training. So productivity may also be increased by building workforce that can work as a team and which shares certain core values. Because you may have people who have skills, but people who have bad manners will not help the company to improve. Values are things like hard working, okay, the culture, the values. If employees have a culture of hard work, then that will positively affect the performance of the company. So that's very important. Learners, especially the core values. It's sometimes important to consider core values first before skills. All these have to go hand in hand. The core values and the beliefs held by the management and the employees determine how the business responds to challenges. Because there are always challenges at the workplace. There are always challenges within the business. There are always challenges from external sources. So the core values of the employees plus the management will now determine how the company responds to these challenges, because these challenges can either break the company or the business, or it can make the company grow. All right, so personnel knowledge, personnel skills, and personnel values will determine the success of a business. We are discussing personnel under internal environment because the management has the control on which employees or personnel will be hired. Okay, another factor we are going to discuss is number 4. We have financial and physical resources. Financial and physical resources, two things. Financial is from the word finance, then physical resources. There are many different types of resources. This personnel is also a resource. It's called human resource. Then we have physical resources. Then we have financial resources. So resources can either be in relation to personnel or finance or physical resources. Physical resources include things like equipment, machinery, motor vehicles, land, building. These are physical things. So learners, for a business to provide goods and services, it requires resources such as money or finances, and also resources, the physical resources such as equipment, manufacturing equipment, plant and equipment, and so on. So if a business intends to produce a new product or a new good, it must determine whether the existing production facilities such as machinery, equipment will be used. So if a company or a business wants to introduce a new product in the market, it has to consider whether the existing physical resources like equipment will be used to produce the new product. Okay? So a business also may be required to combine a variety of resources such as finances, equipment, machinery, and so on, in order to run effectively. Okay? So to produce goods and services, resources are required. If you are producing, say, videos, okay? Because videos fall under services, then you require video equipment, you require machines, you require computers, and so on. If you are to produce, say, motor vehicles, if you want to manufacture motor vehicles, then you require physical resources. You require plants, you require machinery, you require equipment that is needed in manufacture of motor vehicles. So you'll also need money, because for you to produce motor vehicles or cars, you need raw materials. Okay, a car has different types of materials. We have metal, we have bronze, we have rubber, and so on. So you need money to buy those raw materials. So that's why you see learners, we are talking about finances. You need equipment, you need money. You also need money to pay the workers. These personnel, they need to be paid. When they are working, at the end of the month, they ought to be paid. If you don't have your own houses or premises that will house these machines, then you require to rent or to hire buildings. To hire buildings, you need money. So that's why I'm saying that for a business to provide goods or services, it requires resources. You need money, you need equipment, you need machinery, and so on. Now, if these resources are not available, or if these resources are difficult to acquire, then the business may not succeed in achieving its objectives. And one of the objectives we've mentioned repetitively is making profit. Last lesson, I also said other objectives are growth. Okay, business may require to grow. And by growing, we say the business needs to increase in size. Increase in size of a business may tell you that the business is growing, or increase in output. If the business is increasing the products that it's manufacturing, then that business is growing, okay? Or sales volume. If there is an increase in the volume of sales, then that business is also growing. So the finances, or the financial resources and the physical resources, these are resources, these are factors, these are conditions within the control of the company or the business. The business can acquire these resources, physical resources. It can get money, okay, either through loans or capital injections from the owners. So this is within the control of the management. And that's why it falls under the internal environment. It falls under internal environment. We said internal environment are factors or conditions which are within the control of the business and which affect the operations of the business. So if the business acquires or is able to afford, all right, or if these financial resources are available, then the business will achieve its objectives. But if they are not made available, because the company may have the money, but the management has not decided to buy these physical resources. So again, that one will lead to failure in achievement of business goals or objectives. So financial resources and physical resources is another factor that we have discussed. Then moving on, 1, 2, 3, 4, 5, number 6, this is a straight line. Number 6 is research and development. Research and development. Research and development. Now, research and development is an important factor for success of any business. A very important factor. If a business has to grow or has to expand or needs to survive, then the business must invest in research and development. Research generates new ideas. Through research, the company comes up with new skills and better methods of doing things, better methods, cheaper methods of producing goods and services. So a business has to market and consumer research and development. We are talking about coming up with new ideas. These new ideas help the business to come up with new products. And you can only do that if you are carrying out research and developing these new products and services. when you are developing new products and services, you need to carry out experiments, which sometimes may fail, okay? Though you have invested, you may find that some experiments may not work out. You may need to repeat the experiments. So research and development of new products, new services. So research, okay? New ideas, new products, new skills, better methods of doing things. Now, again, a business may need to do what we call market research. Market research. When a business has come up with a product or even the existing products, then the business has to carry out market research or consumer research, okay? That has to be done on a regular basis because the needs of customers do change. Customers change their needs. So the business has to study consumer behavior so that you can respond accordingly, so that you don't end up providing goods that are not needed by consumers, okay? That is very important. It's a very important factor. We are talking of research in building new products, developing new products. We also have research that can be conducted in trying to understand the trends in the market, the needs of the consumers, the tastes and preferences, are they changing, and what are the customers requiring at the moment. That has to be done regularly, all right? And also how they can improve in order to outdo their competitors, okay? Because we say that in business you could have competition. Competition means other businesses that are competitors are just the other businesses that are offering similar products that the business is also offering. So in order to woo customers, in order to win customers, in order to improve, to increase sales, then there is need to conduct market research. Now, research also assists in development of new products. Development of new products, unique products, and services that may attract new consumers or maintain loyalty of the existing consumers. So what am I saying? I'm saying research assists in the development of new and unique goods and services that may attract new customers or that may help maintain the loyalty of the existing customers. So research and development is an internal factor, okay? It falls under internal business environment. So learners, you have discussed 1, 2, 3, 4, 5, 6 factors. The first one is objectives. And objective in lesson 1, we mentioned that the business has to come up with strategies, remember, strategies, and allocate resources. We discussed management policies. We say that management policies are guidelines, management guidelines. These are the plans of action that help the company run or achieve its objectives. Okay, these are guidelines. The management has to come up with guidelines on how the business is going to operate. And these guidelines may be in relation to the relationship between the company and the owners. Yeah, it could be policies, like policies concerning payment of dividends and so on. There could be policies in relation to suppliers. Company can come up with a guideline on how the company or the business is going to deal with the suppliers. For example, there could be a policy that suppliers should be paid after 2 months. Okay, that is a policy that the suppliers will be paid after 2 months. Or suppliers should be paid cash. Credit period of 2 months or 3 months or whatever period of time. Or there could be a policy where suppliers are paid on cash basis. So these policies can affect the business, the achievement of business goals, either positively or negatively. Learners, we also talked about management styles. Management styles. We say that there are those managers who may have what we call a participative approach, where they involve employees in decision making. There could be another style where management makes all the decisions without involving employees. So both styles may be advantageous. There could be advantageous or disadvantageous to the business. Then there is the factor on personnel, which we discussed today. Personnel. This we said are employees. The company should hire employees who are knowledgeable, who are skillful, and who share the core values of the company. Okay, core values. If the company, the business employs workers who are skilled and who have knowledge and they hold certain values, good values, then that company is bound to succeed. Then there is financial resources and physical resources. Financial resources and physical resources. For a business to provide goods or services, it requires resources such as finances and equipment or machinery and so on. We gave an example and say that if a business intends to produce a new product or a new good, it must determine whether the existing production facilities such as machinery can be used. And if a new good requires new machinery, then financial capability of the business will have to be considered. If the company wants to produce product A, then it's important to consider if the company has the production capacity. Are the production facilities able to produce the new product or not? Okay. Then we also say that under financial resources that a business must be able to combine the available or the various resources such as finances and machinery and so on and land and so on to be able to run effectively. Okay. We said if these resources are not available or are difficult to acquire, then the business may not succeed in achieving its objectives. Then lastly, we discussed research and development as an internal factor. Research and development. We said is a very important factor. For a business to succeed, research and development is very important because research, we said, generates new ideas, generates new skills. The business through research can come up with better methods of doing things, of producing new products and so on. So a business has to market also. We said a business must market its product. For you to market properly, you need to carry out consumer research, market research, consumer behavior, and so on. So we said research and development also plays a major role in the success of a business, and we say that we measure success of a business by the profitability of the business, by growth of the business, and also the stability of the business. So these are factors that we've discussed under internal environment, and we said in this subtopic, business and this environment, we say that the environment of a business can be divided into two, internal environment and external environment. In the next lesson, we will discuss external business environment. That will effectively mark the end of our today's lesson. And before we take a break, I'll give you an assignment. This is your assignment. Explain how the owner of a business can influence its internal environment to achieve success. Your assignment is explain how the owner of a business can influence its internal environment to achieve success. Thank you, learners, for joining our e-learning platform. We are determined to ensure that you have all the content that you require to complete your secondary education. All this content we are trying the much we can to ensure that it's available on all platforms. We have a website where all these videos are stored. You can download and study offline without internet. These videos, we also made them available on Facebook. You can visit our Facebook page. Our videos, we have a timetable which you can follow to learn from our Facebook page. Furthermore, these videos have been made available on our YouTube channel. If you go to our YouTube channel, dubbed Manifested Publishers, go to YouTube and search Manifested Publishers. You see we also have a timetable that will allow you to access this material so that you can continue learning, because remember, learning never stops, regardless of the circumstances that we are operating in. So make sure to either log into our Facebook page or the YouTube channel or go to our website. Your choice is yours, but ensure that you study. Whatever happens, ensure that you study on daily basis. These videos we have a daily timetable for all students, ranging from grade 1 up to Form 4. Okay, so there is a timetable for every class. Those who are appearing in grade 1, we have a timetable, daily basis. You have lessons that you can attend on daily basis. Thank you, and God bless you. Bye-bye.
CPA students can now access top-notch lecturers anytime from anywhere. Download CPA video lectures from www.manifestedpublishers.com.
Welcome to Manifested Publishers.
Welcome, learners. My name is Stephen Kariungi, and today we continue with our topic of discussion. The topic is acids, bases, and indicators, topic in Form 1 chemistry. So at this point, we are going to discuss commercial indicators. And this is in addition to what we discussed the last time, whereby we discussed the extraction of indicators from plant extracts. And we saw the disadvantages of those indicators that are obtained from plant extracts, and that is now why there is need for commercial indicators. So commercial indicators give consistent results. They can be stored for a long time for future use and so on and so forth. And we'll have various examples. We have, for example, an indicator that is called litmus. Litmus can either be in form of a solution called litmus solution. It can also be in form of a paper called litmus paper. We have other commercial indicators such as methyl orange. There is phenolphthalein. There is screened methyl orange. There are many. There are bromothymol blue. So there are several. But of course, we'll only mention the common ones, the ones that are commonly used in our laboratories. So we can say that common commercial indicators include, we have litmus, we have methyl orange, there is also screened methyl orange, there is phenolphthalein, there is a bromothymol blue. So all those, they are commercial indicators, but we'll mainly mention the litmus and the methyl orange and phenolphthalein because those are the common ones that we actually use. So we can first of all say that these indicators give consistent results. So they cannot give you results today and then tomorrow they give you results that are different. So they'll have to be consistent. That's why they are more recommended as compared to the simple ones that are obtained from plants. So these ones are basically the ones that we use. So they give consistent results and can be stored for future use. So at this point, we'll have a table showing the effects of commercial indicators on different solutions. Effects of commercial indicators on different solutions. So we'll put these as a table. So we'll have a solution being tested in the first column. Then here we can use litmus paper is one of the indicators, or we can still use the litmus solution. They just give the same results. Then we have methyl orange indicator, and then we have phenolphthalein indicator. So for example, we can take lemon juice. If you test it with litmus paper, the color turns red. So you can mention somewhere here that this is the color obtained using either of those indicators, using litmus paper. So when using a litmus paper, the color obtained is red with lemon juice. When you use methyl orange, the color here is pink When you use phenolphthalein, it's colorless. So you can see that different indicators give us different colors with the same solution. On the other hand, if we use something like soap solution, with the litmus, the color will be blue. With methyl orange, the color will be yellow. And with phenolphthalein, the color will be pink. So you can see all of them are giving us different colors. We take an example of hydrochloric acid. In litmus, it will be red. In methyl orange will be pink. And in phenolphthalein will be colorless. So we can observe something here, that hydrochloric acid is behaving the same way as lemon juice in all the indicators. And that is an indication that lemon juice and hydrochloric acid are acidic. They are acidic. But soap solution is not acidic. That's why it's giving us different colors. If you take something like caustic soda solution, so this one will behave like the soap solution. Blue with litmus, yellow with methyl orange, and pink with phenolphthalein. So 2 and 3, they have similar properties. That means caustic soda solution and soap solution, they are bases. They are bases. That's why they are giving similar colors with the various indicators. If we take an example of distilled water, the litmus is purple, the methyl orange is orange. That means the color remains orange. Litmus, the color remains purple. Phenolphthalein, the color is colorless. It remains. So for distilled water, this is neutral. It's neither acidic nor basic. It's not behaving like the others. That shows that it has its own properties that are different. So the list can be long. We can have as many chemicals as we want. But something that is worth mentioning, we can say that from the above table, we can say A, lemon juice, hydrochloric acid. We can still use sulfuric acid. All give similar. They give similar colors with different indicators. They give similar colors with different indicators. They are all acidic. All of them are acidic. That's why they are giving the same colors. Lemon juice, hydrochloric acid, even if we were to use sulfuric acid, it will give us all those colors. So that's an indication that all acidic substances will behave like that. On the other hand, we can say that soap solution, caustic soda solution, we can have potassium hydroxide, sodium hydroxide, and others not on the list. They also give similar colors with different indicators. with the different indicators above, they are all basic. So they are all bases. So they are bases because they have their own color that they are giving us that is different from those that are acidic. Remember we said that the work of the indicators is to tell us, is this an acid or is this a base? If it is an acid, it gives you a certain color. If it is a base, it gives you a different color. Then we have distilled water that is giving us a completely different color from the others. So here distilled water, we are saying that it is neutral because the litmus remains purple. It doesn't turn red or blue. The methyl orange remains orange. Phenolphthalein remains colorless. So that is an indication that they are neutral. So you can say that distilled water and common salt solution even sugar solution can also use it there. They do not change the color of indicators. They do not change the color of indicators above, i.e. they are neutral. They are neutral. And neutral means neither acidic, they are neither acidic nor basic. So they are not acids and they are not bases. Distilled water, common salt, sugar solution, those ones have no effect on the indicators. But you can see that lemon juice, hydrochloric acid, sulfuric acid, those ones are acidic. They are giving you similar colors. If it is using litmus, all of them are red. If it is using methyl orange, all of them are pink. If it is using phenolphthalein, they are colorless. So if the behavior is the same, then it means that they have similar properties or they have the same properties. So we can summarize that again and say that we can have the indicator, then we can have color in acid, base, and neutral solution. So for example, we can start with the litmus. In acid, it is red. In base, it is blue. In neutral, it's purple. So we are summarizing this from here. If it is methyl orange, in acid, it is pink. In base, it is yellow, as we can see there. And then in neutral, it's orange. And then finally, phenolphthalein. As another indicator. In acid, it is colorless. In base, it is pink. In neutral, it's also colorless. So this is the conclusion that we've got from the first table. We have an indicator, and then we have the various colors that it gives us. If, for example, the solution is acidic, if it is basic, and if it is neutral. So color in acid, litmus is red. In base, it is blue. In neutral, it's purple. Methyl orange, in an acid, it is pink. In a base, it is yellow. In a neutral solution, orange. Phenolphthalein, if you put it into an acid, it is colorless. In a base, pink. In a neutral solution, colorless. So that tells us that indicators give us different colors in an acid and different colors in a base. So you can have an assignment. So the first question, complete the table below, the indicator, the color it gives in an acid, the color it gives in a base, and in a neutral solution. So starting with phenolphthalein, methyl orange, litmus paper in each. And then question number 2, why is it advisable to use commercial indicators in the laboratory? Why is it advisable to use commercial indicators in the laboratory? So we'll stop there. Until next time, goodbye.
Welcome to Manifested Publishers.
Hujambo mwanafunzi wa darasa la 8. Karibu katika kipindi hiki cha Kiswahili ambapo tutasoma msamiati. Na msamiati ambao tutasoma ni msamiati wa akisami. Naamini kwamba unatamani kusikia mengi kuhusiana na akisami, hasa katika lugha ya Kiswahili. Lugha ya Kiingereza unajua nyingi tu, lakini sasa leo tunajifunza akisami kwa lugha ya Kiswahili. Nataka hamu yako iwe katika kujua hizo akisami ni nini, na zaidi akisami zenyewe zinaitwaje kwa Kiswahili. Basi lisije kuwa tisho tena, kwa sababu leo hii hilo tatizo tunalitatua. Kwanza kabisa, wacha tuangalie maana ya neno akisami. Akisami, unapoeleza maana ya kisami, unaweza ukasema ni sehemu ya kitu kimoja kizima. Ni sehemu ya kitu kizima. Sehemu ni sehemu ya kitu kizima. Hiyo ndio akisami. Kwa lugha ya Kiingereza ni fraction. Ni fraction. Ni fraction. Lugha ya Kimombo ni fraction. Hivyo akisami ni fraction, ni sehemu ya kitu kizima. Ni sehemu ya kizima, sehemu ya kitu kizima. Eleza ni sehemu ya kitu kizima. Ama pia kamili. Najaribu kumaanisha nini? Nataka